So this is technically the second video that I'm going to upload, and this video is on exponential growth and decay. The first one was on square roots and cube roots, fourth roots, all those radicals. Right here we're doing exponential growth and decay. So if we take a look at number one, this is a decay function, and step one is to ignore h and k, but there is no h and k, so I'm just going to jump right into my xy table. You also want to use consecutive integer inputs. And just because we have from -3 to +3 doesn't mean we're going to use all of them. Which is the easiest one to plug in out of all these numbers?
0.
Plug in 0 right there. 1/4 to the 0 power is what? 1. Anything to the 0 power is 1. And now what you need to do to get to the next term, I mean, you could plug in a 1 right there, and then you get 1/4, and you could plug in a 2 right there, and so on and so on. Or you could just use the decay factor and decay this number 1 by 1/4. So 1 times 1/4 is 1/4. And then 1/4, when you multiply that by 1/4, you get what? 1/4 times 1/4? Not 1/8, 1/16. And then if I wanted to, I could multiply it again, but you get a huge number, 1/64. But the point is, 1/16, you can't even draw that anymore. It's so small, it's so close to 0, it's going to look like your dot's actually on the line. So let's use that same pattern backwards. Instead of multiplying by 1/4, which is really dividing by 4, let's go backwards, which is multiplying by 4. So this next one up would be +4, and the next one up would be +16, but I'm going to stop right there. I can't even use 16, it's off the graph. So let me graph the 0, 1. 0, 1 is right here. Let's graph -1 and 4, which is right here. And that's it. The -216, it's already off the graph. Let's go in the other direction. How about 1 and 1/4? 1 on the x, let me show you. From the origin, you're going to go 1 on the x and 1/4 of the way up. That's actually half of the halfway up. So it's not even halfway. It's halfway up to the halfway, if that makes sense. So I'm going to put it right there. And like I said, the next one, 1/16, it's so close to 0 that it looks like it's touching the line. And we already know that it infinitely approaches, but never actually touches. Now, if I actually had a +3 or a -5, if I actually had a k value, we would have to shift these coordinates in that k direction. But there is no k value, so we don't have to shift anything. So I just need to connect my dots, put an arrow, which it already has, put an arrow up this way, and you're done. That's it. Now, the only other things we could do with this graph is state the domain range, and that's about it. So what is the domain? And don't forget, x equals, guys. You need to put the x equals. And the range, you're going to say what? Y is it above? It is greater. It's above the asymptote value. So y is above 0, right? Let's try the next one here. Whoa, that's not good. So this next one, again, you're going to do the XY table. You're going to do consecutive integer inputs. And we're going to ignore the k value of -5. We're going to focus in on the exponential growth part, just the y equals 3 to the x. And we're just ignoring k so we could actually look at the pattern and use the pattern. When you plug in 0, the easiest number, you will get out a 1. And then from there, you could use the growth factor of 3 to get to the next output. So what is the next output? What's the next output? After 1, if the growth factor is 3. How do I get to here if you know that the growth factor is 3? You're going to grow by 3. So you're going to say 1 times 3 is 3. And the next one? 9. And you know what? We're already off the graph. I can't even use 9. It only goes up to 7. So I could stop right there. But I could go backwards if I wanted to. But I already know that 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. And we know that the next one's 1/9. But at the end of it all, we know it's approaching 0. So let's graph what we have here. We have 0, 1 right there. We have 1, 3 right there. We have 2, 9. That's already off the graph, somewhere up here off the graph. And then we have -1 and 1/3. Let me show that again. From the origin, you go -1 and then 1/3 of the way up. It's not even halfway up. And we could just already stop right there because we know that the other ones are going to be so small it looks like they're actually on the x-axis. And this is what we call the asymptote of the parent graph. Now, this is not the actual graph. Our actual graph needs to be shifted how many units where? We need to shift this thing where? 5 units down. Why? Because the k value is -5. And we know that the k value is really our asymptote value. So at the end of it all, this is our asymptote, y equals -5. So let's shift every single one of these coordinates down to this asymptote. Shift this one 5 units down, 5 units down, 5 units down, and we're going to get this new blue graph. Let me just connect the blue dots. And there is a perfect graph of that exponential growth function that got shifted 5 units down. So there is another graphing problem on the back side. So we need to graph this one right here. This is an exponential decay function. Let's start again by ignoring your k value. So we could use the xy table and use the pattern. So there's my xy table. Those are consecutive integer inputs. Let's start by plugging in 0. When I plug in 0, I get out a -4. Because right here is 0, that'd become 1. 1/2 to the 0 power, that's 1. And 1 times -4 is -4. Now, I could plug in 1, get out an output. Plug in 2, get out an output. Plug in 3, I could plug in these negatives. But that's a lot of math. I could simply now use my decay factor of 1/2 to get to the next output. In other words, if I were to take this output of -4, and if I were to multiply it by 1/2, it's going to give me what? What's half of -4? -2. And then what's half of -2? -1. And what's half of -1? -1/2. And if I kept going, it would be -1/4, and then -1/8, and then -1/16, and it keeps getting smaller and smaller, closer to 0. In the opposite direction, multiplying by half, right? Or multiplying by 2, I'm sorry. So in the opposite direction, 1 times 2 is 2, -2 times 2 is -4, -4 times 2 is -8. But you know what? This graph doesn't even go to -8. I think it stops at 7. So I'm just going to stop right there and graph what I have. Now remember, this is the parent graph so far. So let's graph 0, -4. And that is, let me move it up, 0, -4 is right here. And then the next one, 1, -2 is right there. And the next one, 2, -1 is right there. And then 3, -1/2 is right there. And we said it keeps getting closer and closer and closer to 0 till it actually looks like it's touching. Now this is the parent graph. Your actual graph is where? Has an asymptote where? Where's your actual asymptote on your parent graph? 3 units up. Y equals 3. So you could draw the asymptote right at 3. And you know that your graph has to end up on that asymptote. I mean, it never actually touches, it just infinitely approaches. And after that, all you need to do is move up every single coordinate, those 3 units, because the k value is 3, +3. So you move each of them up 3 units. So if I take the furthest left red dot and move it up 1, 2, 3, I end up right here. The other one, 1, 2, 3, right there. The other one, 1, 2, 3, right there. The halfway one, up 3, I end up right there at that halfway. And I know it ends up looking like it's actually touching the asymptote. All I need to do is connect the dots, draw an arrow. I'm done. What's the domain on this thing, guys? X equals all real numbers. How about the range? Y is less than 3. Good job. That's about it on the graphing part, but there is going to be a couple other ones where I say identify whether it's growth or decay, and also state the domain and range. So what do you guys say about number 17 right here? Is that growth or is it decay? It's decay. Good job. Because from left to right, it's approaching the asymptote. Couldn't have said it better myself. Remember, you always look at graphs from left to right, kind of like reading a sentence. You read it from left to right. So if you're going from left to right, you might be thinking, oh, it's growing. But it's not growing. It's actually decaying to the asymptote value of 2. So here's the asymptote. And from left to right, this guy, it looks like it's growing, but it's not. It's actually getting closer and closer and closer to that asymptote value of 2. So that's why it's a decay function. It decays to the value of 2. Now, in order for it to be a growth, it has to grow to positive infinity or to negative infinity, not to a certain value. Once again, in order for it to be growth, it has to grow to positive infinity or to negative infinity, not to a certain value. And we all could clearly see that this blue graph from left to right approaches the value 2. It doesn't approach positive infinity or negative infinity. It approaches the value 2, the asymptote. So how about number 18, growth or decay? Growth. From left to right, it's definitely growing. Now, you're probably thinking it's going down. Isn't that decay? No, it's a growth in a negative direction. Once again, it's like credit card debt. You have a bunch of credit cards, you don't use them, your balance is 0. That's the y equals 0 right there, the asymptote. But then as you start going and start wasting money, your debt increases. So it's growing in a negative direction. So I almost forgot to state the domain and range. So how about number 17 right here, the blue graph. What's the domain?
X equals all real numbers.
Always, thank you. X equals all real numbers. And how about the range? Y, it's either above your asymptote value or below your asymptote value. So what do we say? Y is what? It's below. So in terms of an inequality, what does below mean? Less than. And it's less than what?
2.
Less than 2. There we go. Perfect. How about number 18? The domain, obviously, X equals all real numbers. That's like a free point. Free points on the test. But the range is Y what? Is above the asymptote value or below the asymptote value? Below. So what do we mean by below?
It's under.
Less than, yeah, under. Less than what? 0. Because the asymptote in this case really is y equals 0. Okay, so that's the second section of the test. On the next video, I want to go over the third section, which is what we learned most recently, the geometric sequences and writing equations of geometric sequences.